Looks like I lost my sponge from my microphone. Where? No idea. Looks like I lost it. Maybe it was last stream? Anyway. Give me a second, so... Need to check. Get my home. Otherwise I'll need to order extras. On test 1 2 1 2. Like fine. Okay. I'm a little early. Hey XF! Welcome! Was just about to start. Was plugging in my micro. Forgot. Yeah, I'm a little better today. I've been pretty down past couple days, but today I'm a little better. Feeling lighter. Feeling much better. Can breathe better. My voice is still a little affected. I still have a little cough, but should be fine in a couple days. Hey Joseph, how are you, my friend? So officially, well, I wish you get better as well. So, good evening, good morning, good afternoon. Yeah, I'm a little better. Feeling better, feeling lighter, a little stronger. Was pretty weak last couple days. But yeah. Okay, so I decided to make an extra stream. Because... Well, just because. Why not? So I'm gonna remachine 2 parts. It's not that they weren't fine, it's just they are not fine for me. They would work perfectly. I wasn't pretty happy when we first machined them. So I'm talking about these 2 pieces. So these will hold the focus. These will hold the X motor, I believe. And looks like the pieces moved. It's not that they are unusable, because they are usable. They are just not in my specs. This one is fine. This one looks like when it was drilling, I think. Since it has a long arm, it was making a lot of leverage. Why don't you focus properly? Probably low light. So probably when it was drilling, since it has an offset from where the piece is actually old, it probably tilted a little bit and moved the part, and I don't like it. So I'm gonna redo. I'm gonna remake them. I'm realizing another problem now, but there's nothing significant. No, I changed the programming, just some tweaks. Basically what I did, so I actually did a mistake the first time when I machined them. And the problem was, I was like, it's a small drill, like not very thick, but I forgot this thing was while hanging. So basically I changed the way the drill will do. So instead of going straight down, I'll go just keep braking. It's gonna be easier on the part, it's gonna be easier on the drill. A little slower. Other than that, it's all the same. The only change pretty much I made. And we need to change to... We need to modify the original parts. So these two parts, you don't need to do them on the CNC. We just need to add a few drills and a few threads. So you don't need to do on the CNC, but since we are working on the CNC, why not? And actually I advise against doing it on the CNC because it's way easier to fuck it up on the CNC other than... Really? Too much torque? Let's check. Let's do a quick check. So I have a ruler here. A pretty straight ruler. So quick check looks fine, like this. Like this. Yeah, it looks decent. It's not perfect, but it's perfect enough for the usage. Yeah, they look decent. At least this one. Ah! Ah! That's bad. True, Rex, and welcome. So I am hoping that we don't have a pleasant surprise or a power outage, because there's a storm passing by. Hopefully, supposedly it's not gonna go... Yeah, this one looks cool too. I actually don't own... Yeah, this is fine enough. I mean, they are not perfect, but they are good enough for the use they're gonna get. Actually, this one looks a little bold. Let's check with the mic. So yeah, this is not how I should check it. I should check it on a granite plane, but it's... Well, actually, we may check them later. We can do a detailed inspection later. Where's my mic? I found my mic and I lost it again. I think yeah, it's here. Okay, I'm gonna check dimension, the thickness in a few places. I know it won't give me the flatness, but... So we have 1497. Ooh. Okay, we have 2/10 of a millimeter less on the middle. We have 90, so we have 97, 97, 95 on the middle. We have 98 on this side. Yeah, it's a little crooked. 95 as well. And 99 in here. They are not ideal, but 99. Within a couple cents is fine. Let me check another one. The other one, actually. So 97, 96, 97, 96, 96, 96, 94 and a half. Yeah, it's a little as well in the middle, so probably from Hey Shrimp Father. Well, we'll see. Worst case scenario, I'll deck it. I'll make a deck passage. How long is this thing? Yeah, I can do it in one pass. Well, worst case scenario, I'll make a new one. Especially since since these ones are pretty fucked up. Well, the holes are too deep, as we talked about in a cam or in a CAD. Quite difficult to machine these properly flat without, especially in production, without being careful, because it's easy to tighten it and actually bow it. So the idea is to tighten just enough, hold the piece and not over tight, because otherwise it will bow. Well, we can check. Yeah, we can check on the machine in a minute. We'll check it on the machine in a minute. I'll set it on parallels. Just finger tight it on the vise, and I'll pass the indicator on the plate. So we're gonna check them in a minute. So yeah, let's get to it. So first, let's machine the parts that need to be machined, which is with this piece of sock. And if I feel the need to deck it a little bit on those two, I will. Not the end of the world, but they are already so thin in the, because they made these holes too deep on this side. So I need to check how is this side, and hopefully this side is good, or I'll deck first this side if I need to, and after decking this side, when I say deck, I say do a cleanup pass or two. Well, I mean a cleanup pass, and then I'll flip it and I'll see how is the other side. And yeah, so let's get to work. Hopefully it's fine, or fine enough. So I'm gonna need a 56, not a 56, a 46. Let me put my gloves in. I'm more concerned about the flatness of the profiles, the aluminum of the frame, than actually the plates. Not this one. So let me see if I can get away with a 44. So we need 37 for the. No, that's too close. What do we have in here? 48. 48. So that one should be 46, right? Yeah, 46. Okay, so there we are. Machine is warmed up. Hey baby, how are you, my friend? Okay, manual. Ooh, we have a frame drop. Where am I connected? Let me check. Should be fine. Let's see if we have more problems. So manual. Why are you on A? Okay, since we are close here to the X, let's start on the X. That's fine. Set coordinates X0. Let's set Z. Set coordinates Z0. Set coordinates Y0. Set coordinates Y minus 7.45. And let's check the X. So X should be 65.35. And we should be good to go. So I'm remachining these two parts again. So these are the X motor brackets, so the parts that will hold the X motor. Just because I don't like how they came out on the first machining. This one specifically moved when we made the drill here for the screw. Because I went full power on it and it has a large leverage, it probably moved. So I changed the programming to do small incrementing holes instead of go drill full depth. But yeah. So they are fully functional. I just don't like them, so I'm gonna remachine them. A small piece of aluminum. It doesn't take long, only 2 setups. So I'll just go and do it again. So program, fuck. Give me a minute, I need to grab the USB drive, I forgot it on my computer. So 1 minute. I'm back. I'm back. Okay. Let's plug in the USB drive. Let's load the USB drive. EMSP, Milo. There we go. So this is the X motor. First setup. First tool. Thing looks fine. Auto. No, I made it. The top hat on my Skyla, I just made it myself. I just bought a few pieces of profile, I cut them and I printed corners. I used those commercial corners for extra strength because I like to hold it from the top hat and that machine is heavy. And then I cut some panels and put on it. Just the quick and dirty way to do it. Let's hope it cleans up. Not a big deal if it doesn't, but so I'm doing a spring pass now. This is a very high and thin piece, so I'm doing a spring pass to make sure that everything is cut, and if you see, it will be ships after the second pass. You see, it wouldn't hurt to do a third pass actually. A long mill, a long cut on a thin part, so makes sense we do a spring pass. Hey Kago! Yeah, now I definitely see differences. Okay. And I'm always hitting these goddamn camera. with my bumpy head. So we need tool number 2. Right. I also changed to make these holes from this side, and on the other programming we had the holes on the other side, which made no sense, but so now tool number 93, which is a 4.2 millimeter drill, which is this one. Yep. Makes absolutely total sense to do these drills on this side instead of the other one. I have no idea why I did it on the other side in the first place. Probably it was late in the night and brain wasn't working at full power. So we have one side done. So now another detail that I just remembered, and it's not a big deal, but it is something. So if no, because I would need to use the drill on the other side anyway, and it's a different one, so I don't know. Probably I was sleeping. Okay, so I'm not sure if I'll be able to show it here, but in here we have a step, and this step was intentional to make sure when we are cutting, since we don't have this full length on the flutes, I don't like when I'm cutting the lower part for the tool to be rubbing, hey Simo, on this side. So when I did this last contour, I decked it down less 15 cents of a millimeter all around. So, and we have the origin on this corner here. So I need to take that in consideration when I take the measurements on this origin, to take into account that this origin, it's actually 15 cents inside the part and not actually on the face of the part. So it's not important or on this specific usage, but it's something that we should consider, and we're gonna take that into account. Okay, I'm not feeling like closing that vise. So I'm going to machine it here. If I remember correctly, let me check. How much do we have here? So we have 25 something. So we need something like 30 millimeters high. 20 millimeters high. Let me change the main. Let me move it. Manual. There. Okay, so I'm gonna let me check first. I need to check a few things actually. Yeah, that's fine. Okay, so what I'm gonna do, I'm gonna put a magnet on top of the barrel and the jaw. Not sure if you guys can see the magnet. Well, you can barely see it, a reflection at least. It's there. Let me put this roughly centered though. Yeah, something like that. The magnet is pretty, I don't know, it makes at least, it holds like at least 1 pound of force. So it's fine. So I'm gonna probe on the magnet. I mean probe X on the magnet, not probe on the magnet, everything. So first I'm gonna probe Z. On the parallel. And set Z 0. Now I'm gonna probe X, which is on the magnet. So I'm using the magnet as a stop basically. And you can see the magnet holds just fine the force of the probe. And this probe, it's actually a very strong one. So X. In this case we are X 0.15 because of the offset that I was saying. Because we are 15 in the piece. Let me check if it didn't move because I forced it more. Nope. Everything is fine. And well, I'm gonna see if I have space in the focus it there. I think so. So I'm gonna put, I need to check the orientation of this thingy. So let me open the setup on my tablet, which is charging because I forgot to charge it. So, Mr. Jarvis. Milo X motor mount top. Yes, it's the side to the front. I'm not sure if I'll be able to probe why. We'll try though. I'm gonna give it a good tight grip. Quite a few wagadagas there, because they are two parts and you need to make sure they are well holed. Let me see if I can probe in here. Barely, or barely not. It's either barely or barely not. Nah. Okay. I can't. I need to probe without the part. Fine, fine. So, yeah, okay. I'm gonna type the parallel and okay, so same story. So here should be 0. Actually, it's not 0 because we are 0.5 millimeters in the part, so the part is to that way. So that means that we are negative 0.15 millimeters because we are, so the part is offset to the front. Yes, exactly. So the origin actually is 0.15, so we need to set here, set coordinates y minus 0.15. Like that. The point. And yes, this is something I haven't done on the other parts, but it will be fine. Let's go. Done. And so we have tool number 12. Let me check which one is tool number 12. So yeah, we need to change it. The magic tool. So clear minus 42.89. Fine. And looks like I took it away already. So let me grab it. Ah! Freaking wasp yesterday stung me. My leg. It hurts like a motherfucker when I crouch. Pro auto. Let's go send it. Let's see. Go. 100% fit, 100% rapid. And let's make ships. I could swear I changed this for higher RPM. So now it's counter boring for the screws. Down to 15 millimeters. Hey QC, how are you, my friend? Now it's gonna face. Yeah, I'm better. No more. Still a little cough, still a little drop in the nose, but I'm better. Okay. Tool number 2. For chamferings and spots and whatsoever. I actually have to replace them now. So it should spot really slow, nice. I'm gonna chamfer. Looking good. Much better than the other ones. That's the idea, right? So now I need a 4.6. This one. Right? It's not marked. Yep, this one. So it should step drill them. So not so much force in the part, especially on that side, because of the leverage. Let me remove this guy from here. Now we need the top M5. I think it's the other way, so it doesn't wobble as much. Let's put some oily. And let's see. And there we go. And now we should have better parts. Possibly, approximately the same machining time, just better. Yeah, everything is spot on. I was scared I would mess up the offsets, but no, because of the origin. I'll show the differences when we get to that part, but basically, where are they? They are here. Okay, so this is the original ones. This one. So this one, it's not too bad. The main difference is here on top on the chamfer. I'm not sure I'll be able to show it because of the shiny surface. So you can see a constant chamfer around the top of the part, and on this one not constant at all. You see on this side doesn't have pretty much chamfer, and here it has a big one because the part dropped and the mill pass here the part was low, and here the part was high, and it fucked it up. The spots are non-existent, so no chamfer on where it threads. Here you can see the chamfer on the countersinks are not equal. You have more chamfer on this side. Other than that, it's not equal. And the new ones, we have equal everything. We have chamfer all around. You have chamfer on the actually threads, and you have chamfer on all of the top of the part. So yeah. That's fine. People are busy, I know. Anyway, parts done. These ones go to the garbage. Or maybe we'll use it as infill for the when we do the casting. Anyway, moving on. Okay, so let's take a look. Let's take a look into the elephant in the room. Let's see how our plates. So let me remove this parallel and this magnet. And let's see if we need to deck our plates. We move to the main camera, zoom out, it should be fine here. Let me close this guy and let's work on that one. There we go. Is it my... Oh, okay. Let me turn on my compressor. It was strange. The pressure was low. Forgot to turn on the compressor, the air compressor. Okay, so let me move the machine that side a little bit. Let's open this guy up. A little bit. Come on. Goddamn ships go everywhere. This, my friends, is why wakeovers are a must. And speaking of that, I have the first prototype printing, which it should be done already or right about to finish. But let's worry about that later. Let me... I have a bunch of ships here in between. Let me spray them out. There we go. Okay, let me check the wider plate, which is the... It's the saddle one. I need to... This one doesn't fit, so it needs to be on this one. Okay, let me clean the floor. This is absolutely important that I clean the floor of the vise where the parallels sit. Make sure there's not a forgotten sheep in there. And we can use that's pretty clean. We can use the 40, not the 48s, 44s. I'm not sure if that thing is, I think it's 10, right? It's 10. I'm gonna even use, yeah, it's 10. So I'm gonna use the 42s. Should be fine. No, I'm gonna use the 42s. Means I need to get access to my box, which is always full of stuff on top. So let me grab the 42s. Could grab the 41s. Would be the absolutely ideal, but like that. Now let's grab the thingy. Okay, first I'm gonna machine what I have to machine on them. So let me see the position. Let me grab my tablet. It's charged already. See, people are just busy. Okay, so this one is the saddle plate. So I have it. Where is it? Yeah. So I have it like that. So this one only gets 4 screws, 4 holes in the corners, and what? 1 hole in the middle, I think? 2 holes in the middle. So this one will get 6 holes made, probably a couple threads. Doesn't make very sense. So yeah. Okay, fine. I'm gonna torque it a little bit because I'm only making holes. That's fine. I'm gonna move the parallels a little bit to the middle because I'm gonna need to do 4 holes here on these corners, and I don't want the drills. So we're gonna put 2 holes in 2 holes in here, so one here somewhere, and 4 holes on the corners. The 4 holes on the corners is gonna be 3 millimeters. It's gonna be passed through for M3s. I should do them 3.3 millimeters but I don't think I have a 3.3 millimeter set. And these two should be 3.7. I could do all 3.7 though, but I like the stuff to be tight. So I'm gonna do 3 millimeters and the M4s in the middle. So first, everyone is here. So first let me set the drills that I need. I need to set the 3 millimeter drill, which we haven't used yet. So it's tool 94. To redeem, tool 94, and we need to set it at 29,014 negative. So I'm gonna clear it. Yes. Minus 29.014. Boom. We need to set the top for the tool 12, which is the M4. Clear. Minus 2.32, I think. Let me confirm. I don't want to fuck up again. So M4 top, yeah, 232 negatives, fine. So I'm gonna grab the center of the piece and we'll work from there. Well, fuck. Okay, let me offset piece a little bit so I have access. Yeah, like that. I need to offset it a little bit so I can I have access to the sides of the plate, so I can probe them for white. Oops. Ooh, nice. I was saying I needed to offset the plate a little bit on this direction so I have access on the sides so I can probe why. Because I want to work on the center as usual. I'm not sure. I could work on a corner, but I'm not sure if this plate is machined to spec or whatever. So in the center, it's always the center. Doesn't matter if it's on the right size or not. After machining it, we'll check for flatness. If we need to deck it, we're gonna try to deck it. We don't. Okay, so set coordinates x0. Since we are on that corner already, let's go y. Doesn't need to be spot on, but could be better. It is. Okay, so we are measuring a little under. I'm not sure what is the spec, so I can tell if it's under the spec or not. I would assume. So I would assume it. We are measuring 124.914. I'm assuming it should be 125. Not sure. Or maybe it's 125 or 124.9. I'm not sure. So anyway, it doesn't really matter. So 124.914 divided by 2 So we need to set this to minus 62.457. We checked the X already, right? I think so. That doesn't hurt. Yes, we are dead on. So we can probe Z on the way. So that coordinate is 0. And let's go to the X. Okay, so most likely the spec is 0.9. We are getting 159.884 divided by 2. So we have that coordinates X 79.942. Not a bad idea. Okay, so if I did everything right, let's grab the... Oops. Fuck. Let's grab the programming, BMSP, Milo. What are we doing? The saddle plate. Yeah. So we're gonna do spotting first. We change. Well, okay. This is a problem of my post processor. When I do a drill cycle with different depths, it will move slowly instead of rapid between the different depths. I've been willing to correct this issue since I found it, basically. And yeah, as you guys see, I haven't done it yet, so... Okay, looks good. So 295 or 94, sorry, which is the 3mm, which is this little girl here. Actually, it's a long girl. Should be fine. We are 1.4, yeah, looks good. Hey Diogo, how are you? Okay, so far so good. What kind of cheese grade aluminum is this? The ships are awful. Chinesium. What next? So 91 3.7, which is this girl. Yeah, 3.7. Fine. And now to finish off some tapping. Yeah. Yes, the LDO plates are aluminum. Not sure which aluminum they are. It looks cheesy. I'm not sure if they spec the aluminum they use. So T12, I already changed it, right? Let me check. T12 should be 232. 232, that's fine. Yeah, let's go. Let's see what it does. Not bad. First one done. There we go. Okay, so now let's check. Let's check now. Let's deal with this plate now. And we'll see. Okay, so let's see if this thing is flat or not. So I know my machine is very flat. Very, very flat actually. So the way we're gonna do it, I'm gonna remove everything, clean everything. I'm gonna grab a countersunk. A deburr for the rounds. So on the top side, when I spotted it already chamfered, but on the bottom side, nope, of course. So, and I'm not gonna flip these things just to deburr 6 holes. No point. That's why Noga tools are made. That ensure the vise is clean. Clean under where the parallel is gonna sit. I'm not gonna put it on a corner or on the ends because I just drilled the holes there and the manual deburring may not be flat, may have a little bump or something, so like that. So I'm just pressing on and I'm just finger tightening to make sure that the plate doesn't move. I'm gonna put the probe on the thingy and we'll see if I can find a flat okay. First, well, I just fucked up a way that I had on Y on the middle. Give me a second, I'll focus on the... Yeah, that should be fine. On the Ymer. This is why I like this probe. There. Because we can use it as an indicator. So in here, I'm pretty sure I have a open way on Y to check. So let's lower it. Let's zero it. And let's see if we have a plate or if we have a boat. I think I'm fine. Yeah, we have kind of a boat. So here's where, yeah, we have a boat. So we have 7 cents higher. Yeah. So we have 7 cents higher on the, or 7 cents lower on the middle, which is not a good thing. And let's check in this direction. This direction should be fine, and it is fine. So it means the machine, it was machined like that. The machine, sorry, the plate. Yeah, that way it's perfect. So Yeah. So what should we do? Should we fix it? Or should we see if it's a problem before we actually fix it? Yeah, I kind of understand why. Because they overclamp it. And when they tight the vise, the goes up. Kinda a lot. I know the ways should have some forgiving, but I'm not sure if they are that forgiving. 7 cents, it's kind of a lot. Let's check the other on the other face. Well, it's gonna be hidden anyway, no one will see it. But yeah, I'm tempted to try it first and see if it's a problem. So I'm gonna flip it. No, it's 7 cents. Cents of a millimeter. So it's about 3,000, a little less than 3,000 of an inch. Okay, let's check here. Fuck. I went too far. Okay, here it's not nearly as much, and at least that. So this is probably the first part that was machined. Now here I won't touch it. We have a couple, we have like 1,000. Yeah, here we're not gonna move it. Here, at least that, because this is the side with the really low thickness on the holes. So okay, we are good enough. I would be happy if the other side was like that. So here we are about 1,000 of an inch. Still done, still both, but not nearly as much. It's less than almost a third of what we have on the other side. So yeah, I'm gonna be fine with that. And I assume on these axes we should be fine. Let's see. Okay, I may be getting the chamfer there. No, we are fine. Ooh, we definitely got the chamfer there. Yeah, that's fine. So yeah, I'm not gonna mess with it. I'm gonna make a mark where the problem is. Well, where the defect is. Well, we'll see if it's a problem or not later on. So I'm gonna make a mark somewhere in here with what? My scriber. Should be fine. Where is my scriber? Oh, it's not here. I know if I do it with ink, I'm gonna clean it when we get to... I can center punch it, but kind of a little extreme. Let's see if I find my scriber. My tungsten scriber. Otherwise, my knife can act as a scriber. It's used to, actually. Oh, I don't see my scriber. Oh, found it, I think. Yeah, found it. Okay, I'm gonna make a mark in here and another one in here, so I know these two are high. Okay. Okie dokie, so let's go to the Z plate. God damn, these guys are so dumb. Every time I look at this, it hurts my soul. Okay, let's go to the Z plate. Okay, the Z plate only needs 2 holes, and then there's an extra hole that needs to be counterbored, which is, but it's optional. I'm gonna make it because I designed it, but it's gonna be optional. If you want to do it, if you have the tools to do it, you absolutely can do it. If you don't, no worries, it will work anyway. I'm gonna do the same trick. Actually, this one I don't need to, because it's higher, it's thicker. And we're gonna actually machine it before checking for I'm not sure. We'll see. Anyway, we know, yeah. So we know that if we have a problem, should be fine. We can always shim the carriage on the inside with something like a 2 cents, 1,000 piece of shimming, and we should be fine. If we have problems, I know, yeah, if we have problems now, we know where the problem is and how much the problem is, so it should be a very simple fix. Have I tightened this thing already? Yeah, I think so. Yeah, fine. Let me make sure. Like that. It is like that, yes. And that way we don't ruin the part, and everything will be fine. Gonna keep beautiful. Yeah, that's good enough. Well, if you need, I can make you some. If you're interested in buying the kit of the machine parts, I can machine some of these parts for you, and I'll fix the damn fucking depth issues these guys made on these motherfuckers. So 157.94 divided by 2. So we have 78. Sorry, 97, right? 7897. Okay, so Y0. Set the Z. Yeah, the Z is pretty close. Well, pretty close to spec. Okay, so this one is very close to 110. It's not. 109 dot divided by 2. So 54,993 minus 54.993. Well, sure. Then that's fine. To be honest, I should machine this on my own, because I really don't like that piece of shit of mistake they made over there. I mean, not even 2 millimeters of meat. It's a pretty stupid mistake. And the people who actually made the machining, well, those are not actually the people who actually machined. It's not actually the problem. They just machined according to the drawing they got. But the people who sent to machine should have checked as well. Anyway, moving on. Fuck me. MSP. Milo. Plate. See ya, Beanie. Have a good night. So, what do we have? So first, we have tool number 5, which is this little guy. So it's the counter bore first. So contour board done. Now we should have a few spots and a chamfer. Okay. And the same problem. Now a chamfer. And now we should have 2.8 millimeters for M3 topping. And 5 millimeter drill. Why is the 5 millimeter here? Joseph, what about the side plates? You're not getting those? The full metal jacket or whatever they call them for the side of a column. Or you can source them as well separately. Well, those I'm not sure. Well, I can help you, but they need to be in raw aluminum. What are we missing? Oh, topping. It's like that. Put some juice. I don't think it's necessary. The thing is, probably you can get them cheaper than the aluminum ones. Definitely it's not necessary. I think LDO sell them, right? In separately. Not sure if they the value though. Well, shiny aluminum, I can help you with that if you want. In the stuff that I make the beds of, I can help you with that. Okay, only one hole pokes through. Okay, so let's check for this thingy for flatness. You can dry it on a regular oven, or just get a cheap oven. Worst thing, the only thing you're drying is water, so should be fine. But you can get a cheap oven from the cheapest you can get, and usually if you buy the sand from the bags for the pool filters, usually it's dry, at least dry enough. I'm not sure if I'm gonna bother with drying the sand. Okay, I need to remove everything and make sure everything is properly clean. Yep, that's true. That's why I have two. One was given to me, but it was after I bought. Actually, it's exactly the same model that the one I bought. I bought the cheapest one I could get. Well, not the cheapest one, because I had a target size, so I couldn't go for the cheapest. But the cheapest I found on that with the dimensions I needed, because I do some powder coating as well. And when I need to powder coat stuff, I use that one. And then another one was given, but it wouldn't work. And the problem actually was the thermostat shitty stuff. So I just replaced everything with an SSR and a PID controller, and that thing was working. Kept the fan. Actually, I modified it to be a filament dryer, and now it works for everything. Well, yeah. And you don't even need to go with sheet metal, but yeah. Anyway, so you can get away with some MDF and aluminum foil. You'll be good. It won't burn as long as you don't set it to 500 degrees. Not sure if you're gonna get those as well. But yeah, especially if you use some isolation in between, some glass fiber, or how is that called, the rock stone woven. I'm not sure if it's called like that way in English. Okay, let's check for flatness now. One thing I want to do, and I've been wanting to do one for some time, is a kiln for metal hardening. Rock wool, yeah, that. Okay, let's see. Ladies and gentlemen, please place your bets. Is this thing bowed or not? So this one is thicker, so it would need to be, if it was torqued to the same spec, it should get way less bowing. I see some bowing, not as much, so 3.5 cents, so a little over 1,000. So it's pretty much half of the other one. Yeah, same in here. And now on this direction it's gonna be tough, so I'm gonna check in two places. I'm gonna check in here. So we are pretty much, yeah, we have a little bit, but nothing too much on that direction. A little weird, a little twisted. Let me check there. There. On this direction it's not that important. Yeah, it's fine. So we have about half of the other one, so let's flip it. But we have a little bit on this side. So probably they were set on the same torque, because this one it's 50% thicker and it has about 50% less bowing. So here, let me check. Let's check on the middle. Roughly on the middle. We are done there. Yeah, we are about not even 1,000. A little more in here. Let me check if I'm proper. Yeah, I'm proper seat. A little more than in here. And on this direction we should be fine. Yeah, we have about, yeah. So we have a little bit, and this is the side. So this is the side that actually matters. So I'm not too concerned because this one has the other one. Both sides matter, but this one actually only this side matter. And we have a deviation of two in here. That one should be fine. We'll see. But it's the same story. The outsides are higher than the inside. So if we need to shim the insides. Same story. Should be fine. Okay, so we don't have anything else to machine. And as I said, this one only needs two holes. The third one is optional. So, and if you do the third, you need to take in consideration that you need to counterbore it for the screw head to be. Well, actually you don't. Actually you don't, because the spindle won't be. Yes, you do. You do. You do. Okay, so let me remove the probe. Let me change cameras. I'm gonna change to the controller because it's beautiful. Good night, XF. Okay, so I'm gonna rotate cameras. So give me a second. I need to turn things around in here in order to go to the bench. So we can take a look and we can do some test fittings. See, everything looks good. And talk a little bit because we don't have anything else to machine. I'm gonna power off the big machine. I'm gonna close the thingy. I'm gonna move the camera. Actually, I'm gonna need to cut the signal to the camera. I need to connect it elsewhere. Maybe I don't. There we go. Okay, so let me move stuff around. I'm gonna be off frame a little bit, not too much, hopefully. Not even sure where I'm gonna move the camera to. I haven't planned this, so gotta stick. You guys gotta stick with me for a minute now. Oh, camera. Not even sure where I'm gonna put the camera. Probably in here. Or in there. Yeah, in here. Will be fine. I need power. Oh. Let's see. Looks good, maybe. Looks bueno. Let me gonna disconnect this one. No need. Oops, sorry. Oh, it logs, so it's cool. And now I need this one to be this is gonna be very not ideal, but we'll make it work eventually, maybe, or not. I have a feeling that I'm gonna trip on this wire. Wiry wire. We'll see. Maybe not. Okay. Why don't I have a main? I should have main. Let me activate, deactivate, maybe? There we go. There we go. Good, so we have the plates in. So, what are we checking? So first let me do some cleaning that I need to do. Are my gloves? They are here. Okay, let me turn off these noisy bitch. Quiet. So we are not gonna keep this for long, just making some time. So I'm gonna clean up. We have these holes to clean up, which just matter of using the Naga deburrer. So we have these. We need to be deburred. That carefully, because the parts are so beautiful. Scared of scratching them. I really don't want to do that. Even that, we ain't gonna see it. So actually this is the good one. So this is the one that will be on the front, if I remember. And this one is the one that we yacked. So if you guys are into machining, you really need to get one of these Naga tools, and probably one of these for deburring holes. This one is for deburring everything in general. Actually, they are even good for 3D printers, 3D prints. Sorry. Ah, that needed to go. Okay, so first thing I'm gonna check, since I'm holding these parts. Oh, I have a few more to clean. So I have this one that we made. There's a camera. See. We made the holes on top to the bores, actually, or the screws. So we have a burr inside of the well, this bore. Thank you, Simo. So let's try to minimize. They're not really easy. Fully debar? Fine. Às vezes. Em dias. They're good. Need a left-hand one. Left-hand blade. It's fine. Oh, actually, I can reach it. That one I can't reach from the bottom. Fine. Need to blow my nose. Please. Incoming! Just scare you. Anyway, moving on. Okay, so I brought pretty much all the frames downstairs. I don't think I have anything else. Did that one already? So these are the new ones. Okay, so I have one of the BK and I'll put that aside. One of the BFs, not BK, sorry, FF and FK. So these are the blocks for the. Okay, I have the light. Yeah. Okay, maybe I'll rotate the camera a little bit. That way. And this way. Still catching this bridge. Okay, maybe like that. Let me lift it a little bit. Open it. Lift it would be ideal. If I have the strength. Maybe this angle is better. Let me remove this from here. Okay, so what is on frame? No, I don't like it. Okay, let me try. Nope. Hey AZ Cowboy 1! Well, we are doing some test fitting. I'm just trying to get a good, decent position for the camera. Well, I actually like it here. But goddamn. Change this one. Fuck, it's worse. Here? Yeah, that works good. Kinda, right? I'm not... When I'm reading, I need to watch that way. Oh, let me remove this one. I don't need this. Yeah, kinda works. Just I have the computer here. Ideally, I should have the computer there, but that's not gonna happen now. Anyway, moving on. Okay, so we have the... This is I need another glove. Black gloves and... Oh, I don't need gloves now. Fuck the gloves. Okay, so I have a BF in here. These BFs are a little weird, supposedly. Is this focused? Focus it. So, ideally, well, these ball bearing in here should be moving should be moving kind of freely in here, and it's not. It's moving, but it's gonna be fine. But that's something to keep attention. Actually need to complain about that a little bit. So this is a FK block. So this one, it's the one making the force, and this one, it's just a guiding end bearing. So it's supposed to move to allow the thermal expansion of the ball screw. And probably I'll remove the bearing and I'll do just a little sanding to make sure that it will move, because it's very, 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 very close. I assume it's just the finishing. This black finishing, it's kinda like a paint. I don't think this is black oxide. At least it doesn't look like. So I'm pretty sure if I sand the finish down, it will move just fine. Anyway, I need to check from the other source if they have the same problem. I have them upstairs and I don't feel like going there just to grab one to test. Maybe I'll do when yeah, the print is finished, so I want to test that as well. So when I'll go upstairs, I'll grab one. Okay, so this one is supposed to fit in here, and it does just fine. It has a little play, which is supposed to. We should use something like M36s for that, so let's grab a few M36s. Grab wrench, supposed to be the blue. M36 and M36 like that. This is supposed to have a little play, so we can adjust it to perfectly align the ball screw. So that's why we have the play. So we are fine there. Can leave it for now. Then we should have the BK, so this doesn't really matter for now. The FK, sorry. I'm used to the BK because the BK are the usual. These ones, since are flange, are FK. Like we have a jumping camera. So we need to decast the camera. So same for this guy. Little play as it should. Low alignment, and these ones actually are 4 millimeters. So we need some M4 for those. M4 are on the bottom drawer. Something like 12s. Fine. Let's grab 2. Let's grab the orange. Or this. Orange is not here. On 8, I think. Like that. Be fine. Then I should have brought the little ball screw, but didn't, so I should have brought the I'll need to go grab some stuff upstairs. Well, doesn't really matter. Okay, so the idea is this to mount in here, there, and in here, like this. Same kinda. Then we have where is a little bit. Let me check. It should be here. Yeah. So then we have the locking nut in here. Shouldn't need to be crazy tight, but tight. That. And that. Then we should get these two thingies in here. Probably we need something. Probably. Let me grab some kind of what? It should do. Piece of wood under here. We'll lift it up a little bit. So if I remember correctly, this thing goes down to 15, so something like M425s, if I have some, not sure. M420s will do for now. Let me grab the orange. My orange. Yeah. So this should come in here. Like that. I need something. Let me put my notebook. Something bigger with more area, more surface contact other than these little pieces. Good. So this one should come in here. Fine. So let me go upstairs and grab some more stuff, just to make sure everything fits fine. No, this is everything come out of the machine, Diogo, not brushed. Just out of the machine. Give me a second. I'm gonna grab some more stuff. I'm back. Actually, I think what I needed it's in here. I grabbed some other stuff though, but I need to dry my filament. Very wet. Very wet. All bubbly and stringly. Need to dry it. But the test anyway. So we're gonna be there in a minute. So I bought a thingy, but I think it's the same. Let me open it. Very packed though. Yeah, it's the same shit. Probably they came from the same place. Oh yeah. Yeah, I need to send the finish just sending the finish because I can see this one actually rubbed the ink. Because this thing is not oxided. Not black oxide, pink, and the ink is actually making the part smaller, or the hole smaller, and the bearing doesn't fit properly. So I just need to remove the bearing and do a little sanding, and we should be good to go. Exactly the same problem. Anyway. Not a problem, it's just cheap stuff. Okay, so the stuff that I actually need, I'm pretty sure it's inside this box in here. So let me reach it. Connectors, we don't need connectors. We don't need screws for now. We may need shims. We don't need hinges for that. Don't need connector covers. More hinges. Well, don't tell me. Motherfucker. I don't see them here, but I didn't saw them in there as well. Or either. Probably I'll need to go upstairs again. Yeah, I don't see them. Where are they? Where are the damn couplers? Oh, I don't care. I want assembled. Anyway, doesn't matter. Let's grab a motor. So we have a LDO motor here. So the LDO motor, I don't think, yeah, the LDO motor, there's two ways you can get around this. One is to put some shims in between. So the problem is the motor shaft, it's the, try to, so the problem is the motor shaft, it's the ball screw. I knew this could happen with the original ones, probably with the other ones, because I wanted to keep this thingy as short as possible, so there are actually more options. You can even 3D print some shims to put between this part and this part. And yes, I could make this part bigger, but again, I really don't want to grow this thing because my motor is much bigger than this one. And there's not much space in casa for the thingy. So just a few millimeters, something like 3 millimeters should be fine. Or even you can get a piece of stock like steel or aluminum, 3 millimeters, one on each side, 2 holes, and Bob's your uncle. You're done. Or you can just cut a little bit of the shaft. I'm gonna probably do some to test the original motors. If I'm gonna test them, I'll probably do some shims, 3D print them. It should be the easy way, or just grab a piece of steel bar or aluminum or whatever and do, or even some washers in here, some shims in here. Should be fine. 3 shims and we should be good to go. Let me check my big motor. My big motor probably it's gonna be the same. It's gonna have the same problem. No, actually I won't, because these ones have the very small shafts. I think. At least it looks, yeah, okay, so this one is fine. Let me see if the holes line up. Yeah, the holes line up. That's fine. So let me grab a couple M5 screws just to check if everything does its shoes. And yes, I'm gonna change the connectors. Oh, actually I'm gonna add connectors on this thingy. Now, really could use 4mm Allen. So let me grab a 4mm Allen. Should be this one, I think. 4mm. Should be this one, I think. Ooh. Oh. Oh, something is not lining up, but that's probably, yeah, okay, that's fine. Quite a bit. Let me check what's. I think it's a tolerance game, or I may need to machine some other pieces for this. I think it's tolerance stacking. Not sure. Yeah, I'm not. should have placed alignment pins on. I was avoiding. I may still add them. I know you guys are not seeing, but I need to see what I'm doing. Can't do it if I'm on camera. There's some problem here. Okay, I'll need to machine these parts again. Not, no, that's fine. There's no problem. I don't think there's a problem. No, there's no problem. Everything's fine. Everything is fine. Just need some grab 2 more screws. Everything is fine. I think. Yeah, everything is fine. Everything is aligned. I think I'm gonna change design though to use 4mm motor screws holding the motor, so we have more play for alignment, or one can just enlarge the motor holes a little bit in order to have a little more play, but it should be fine. Everything looks good, everything looks aligned. So yeah, everything looks fine. Okay, one thing I'm gonna test as well, see if the frames get inside here. Well, they should, but so I guess the frames in question, these ones are for this thingy, so these two are for the table. I think I brought all the frames, or maybe I didn't. Maybe I didn't, but it doesn't matter. So this one is supposed to get inside here, and yeah, plenty of play, which is what it should be. What more? Okay, so this one is fine as well. So one other thing. Let me see if I understand this right. So this one, what is this? So this should be the column. And one sad news. So this should be the top of the thingy. So this should be the base. Yeah, okay. I didn't brought all the frame. I think I'm missing one. Doesn't matter. So one of this is supposed to be the column. All of these. One of these supposed to be the Y. Yeah, okay, so this is supposed to be the table. This is supposed to be the Y. Okay, so this thingy. Hey, Kitrell. Or Kitrell, or whatever. Well, thank you. They actually look good. Okay, so this is supposed to be one sad news. Is like LDO only opened the threads that were on the CAD, so it means we're gonna have a shitload of threads to open on the frames, because I have pretty much everywhere I'm gonna need threads except on the column, on the top actually. So yeah, they even Jesus. Yeah. So oh, did they lock tight the holes? Looks like it. No. Okay, so if I'm understanding correctly, this is supposed to be the Y frame. I'm gonna disassemble this. I'm gonna disassemble this one. You see everything is fine in here, no point on taking all the space here. One thing I should check is the net preload stuff, but we're gonna check. I don't have a printed part to disassemble the ball nut. We're gonna need one, so I'm gonna need to design and print a tool so we can remove a ball nut without removing all the or without losing all the balls. So there's that. Let's remove this. I'm considering if I should do some pin alignment in here. I barely have the space, but I do have it. For pin alignments would definitely help with the not that much more work. So maybe I'll do that. At least one. We'll see. What I'm talking about is just to add a couple, add like two holes in here and two holes in here, and put some pins. So when we are, because this will have play from the tolerance of the holes, the tolerance of the screws. So it will have play, and it will help if we add some alignment pin, even if it was just one. Would help a lot. Yeah, wouldn't be a bad idea, to be honest. Let me check some. How is the tolerance on a regular? Not too bad. We'll see. When I assemble it, if I have too many troubles, I'll do that change. If not, I won't. Okay, so let's remove this nut. And one more thing I want to check. Come on. It's just there we go. Probably a burr. So the machining on the ball screw. So this is supposed to get a C-clip here to lock the bearing in, so the bearing doesn't slide down or off. Okay, we have the nuts cut to size, so they should fit. So if we get the thingy here, should fit here with some play, and we are, as we should. Okay, so I'm gonna put away the ball screw. I already tried the ball screw nuts, entered just fine with some wiggle, so we have some margin to work with in here. Everything looks good. The ball screw away. This one actually, it's the one from here, and that I don't know where this thing is. This is the bigger one. No, yeah, that one is from there. Yeah, these three, and plus this, and these are from the bench. And I didn't brought the... okay, that's fine. Okay, so next thing is let's check if... let's take this aside for now. Let's check if the Y, so this is supposed to be the Y-axis. Let me check if the screws align in here. Only I could see. I got really scared for a minute. Well, for a second. Looks like they do, and according to this is 27. There's 7, there, 20. Let me grab some M530s. If I have some. 30s. We have a bunch. So I can only use 2 because there's the only threads I have available. I choose. So these are screws that I removed from the castings on my machine. They may have a little Loctite. Not Loctite, actually epoxy on it. There we go. Good. So like that. This shouldn't be a problem. We center it or align it. Would be better with more screws, but yeah, we'll call it good. We're gonna need to... well, I'll show you when we actually assemble the machine for good. For now, I'm just checking if everything is as it should. Okay, let me remove the stuff from here. I still need... oh fuck, I forgot. I still need to design and actually machine a few parts, but they're gonna be tools, not actually parts. Some alignment jigs that's gonna help with the assemble of all this stuff. Basically just some straight pieces of aluminum, like flat, with a 20mm drill pattern, so I can attach frames and I know they are flat. It's gonna help with all the alignment and stuff. But I haven't designed those and I need to see what I really need. I assume I'm gonna need a few of them. Okay, so here we should assemble the FK part. And if everything goes well, it should one thing that I forgot to tell about, it's so you guys remember, or for those who didn't saw the CAD part of this project, we here on, so the column will come in here like that, and we had a problem. We would need to machine or grind or whatever a little piece of round of 2 millimeters high on the base of the column because of the ball screws, or so the ball screw had clearance. So what I thought, I'm gonna actually put 2 pieces of shim 2 millimeter sheet in here. So I'm gonna lift, basically I'm gonna lift the column 2 millimeters. I think it will work fine, hopefully, but we'll see before I actually need to grind. If I need to grind, I'll ground it, or I'll cut it, or whatever. But if I can get away with a 2 millimeter height here on these parts, so the column will be a little higher, I should get away with the ball screw passing under it like that, and it shouldn't be a problem even for the side plates of this thingy. But yeah, we'll see. Oh yeah, I could swear would have made this thingy a little shorter to make sure it wouldn't pass to the sides, kinda. But anyway, doesn't really matter. Okay, so this side is good. So in theory, we should put in the ball screw in here. Let's check if everything is fine like that. So let me grab the ball screw again. It's actually the one that I was using. This one, right? Yes. Thing should go there like that. It's almost too well. Let me put in the locking nut just because. So then we use, I think it's this, yes, it's this one, that one is round. I forgot to. So this one only has 2 screws as well. You don't need as big screws as that one. You need something M5. Yeah, these 2 ones should be fine for now. Supposed to be button heads. I ordered a bunch of screws that should come in tomorrow. All different sizes, and because I don't really know what I'm gonna need. I'm gonna need. Okay. Then we have this thing. Oh, aiming too high. That's probably a machining. It's probably a cut. The cut is not straight there. We're gonna need to check that with the actual square. It's fine. It's gonna be a little bit under tension. It's gonna be fine. And yes, it's normal that this thing doesn't rotate in here, because that's exactly why we have to round the sides a little bit. I'm pretty sure. Well, it's either that or either the fact that I don't have screws, so this thing is pointing high. No, the cut. It has to be the cut. Yeah, I can clearly see that is not straight at all. Yeah, I can clearly see that this cut on an angle. We'll disassemble it. When we disassemble it, we'll check it. But yeah, shouldn't be a problem. I can even straighten it or shim it, and we'll see. But it's most definitely, yeah, it's like that. So it's making the ball screw aiming up. Either that or Bruno assembled this part wrong. That's also a possibility. Also a possibility that Bruno pulled this part wrongly and is blaming the cut for his mistake. Let's see. It's a Bruno problem. Can be a Bruno problem. Most likely a Bruno problem. Oh fuck, I put a screw where there is no thread. Oh yeah, that's a Bruno problem. Or at least it's also a Bruno problem. Yeah, now we're talking. Yeah, now we're talking. Now we're talking. So maybe it's a good idea to have some kind of label or some kind of mark marking the top on that part, because that part can be mounted not dump proof. So maybe it's a good idea to put a mark on it, marking the top position, like just a little dot, something like, well, it's the bigger part. It actually makes sense. It makes sense. This will need to be all aligned with the ball nut, with the top plate. Everything needs to be aligned after. It's gonna be a pain to mount, but it's gonna be fun. Everything needs to be kind of loose and together, and then start torquing stuff. But yeah, so far so good. What next? What do I want to check next? I want to check these pieces here, which should be these ones. Everything properly aligned. Yeah, I'm really thinking about some alignment pins in here. Not that much harder, or not that much more work, and it will make it way easier. Properly align stuff. Because the thing is, we don't have access to these screws after we assemble the motor. So either we enlarge the motor holes, or I'll just do pin position, and with the precision pins, don't need to be ultra precise. It will help. Come on, what's it? Cross thread. Yeah, these wiggle a lot, so probably I'm gonna be like this for now. But on future ones, I'll add pins. It's not the easier way for me, but it's the easier way for the common human being. Let's see now. Looks lined. Everything is aligned. other one to check. Fine. I need to put the fourth. 3 are, yeah, that one is perfectly aligned. Okay. So it looks good. Fine. So if my calculations are correct, then this part should fit in here. Little stringy. Need to dry my filament. This part should go in here like that. Kinda. Not. Because of this. Screws are, since the screws are protruding, don't have socket heads in here, button heads in here, so yeah, these need to be inside. Pretty smooth. Okay. What time is it? Yeah, okay. Okay, so moment of truth. Let me try some stuff. Everything looks fine. Can check the Z as well, but fine. So I need to finish the holes on the Z. There was a programming error. Let me check something. Haven't seen. So this is supposed to be the Z rail, right? Okay. Not the Z rail, the Z. Where the Z frame, where the Z axis work. So this is should be like this. Yeah, but I can check because of the should be like that. Let me finish these drills in a second, as I have the actually I have the drill here with the it's just a skin, not even a millimeter. Okay, so this thing is what I would say Yeah, 20s, M520s. 16s. 16s will do. So this should be like, oops, okay. I have a fuck up. I need to correct this. So somehow it's fine for me because this part is for me, but I need to correct it. That's what this one is, a proper fuck up. So somehow I made the two holes that will go there, and these two will go here, and then I made one in the middle while we have two. So yeah, that's a mistake. I'll need to change that. But yeah, it will be fine with just 4. Or I can actually modify this part and actually add the other two and leave that there in the middle. But it will, I won't mess with it. I won't mess with it. I'll just use the 4. It will be fine. But yeah, this part as an official mistake. Not a tweak, the actual mistake. And of course the one on... Too stupid. Oh, at least on this one I haven't made holes for that. The bottom piece also has the same mistake. And again, I can correct it or I can just leave it, and I will just leave it because it doesn't matter, especially on that one. So this is supposed to be like this. Official fuck up. Well, if it's the only one, I'll be happy. So same story with this one. I don't know why, but yeah, I made it. Need to leave with it. And especially on this one, it doesn't matter at all. This one is just a support. I don't even care. But yes, I'll correct it for later builds or later kits. That will be corrected. Not on mine. I don't care. I'm not making another part. It's a perfectly working part. Just a small detail. I may change the top one, but I won't throw it away. This one I won't even mess with it. Because this one on the bottom is just a support. It doesn't matter at all. I checked everything fits on the on this so the BK, the FK and the FF parts fit in here as well. Everything looks aligned. I made sure, if I remember correctly, I made sure that so this one, the hole quite goes a little bit onto the frame, but I'm pretty sure I'm gonna remove that, or I'm gonna get another one. Do I have another BK in here? I do. Okay, so I need to fix that up. So it's the Z parts, both of them, with the same mistake. Pretty sure I remember fixing this. Yes, I did. Like half a millimeter away from the frame, so we are good. Could swear I remember fixing this. Little problem actually, so. I think we have that. We are good. We are good. We are here. We should have here and allow to adjust for the poly. Yeah, everything looks good. Everything looks good except that Z. So yeah, I'm gonna call it for tonight. Oh, I'm gonna disassemble all of these. I don't want to. Oh, there's still something I need to, but first I'm gonna disassemble all of these. Tired, sleepy. I'm happy. Only these mistakes. Probably on this one I will actually remove. Just remove the hole on the bottom one. And actually the top one, I could do the same. Yeah. I'll change it. I'll remove. That's a good question, Joseph. Hopefully, maybe on the weekend. Oh, I forgot to grab the mold that I made for the big thingy. You guys seen pictures on Discord, so that's fine. So yeah, hopefully on the weekend we're gonna start casting the epoxy. Not sure, I'm not promising anything, but we'll see. Be nice. I still have to think, because casting the epoxy in here, it's a big deal, because it's a lot of stuff we need to seal. Actually, arrived earlier today, so I bought silicone, of course. We're gonna need silicone, and for the mold that I 3D printed, I bought some sealant, like sealant paint, not sure how to call it, to make it basically paint to basically waterproof. It's kind of plastic or rubbery paint, I need to first coat the 3D printed mold with that stuff, make sure it doesn't leak, and then I will do the mold release coating. Yeah, and that should be good for the 3D printed mold. But on this thing it's on its whole new level, because there's these grooves, these V grooves. This thing has a lot of edges, and we need to make sure they are filled. So it's gonna be tense, to say the least. And especially since I'm using very slow curing epoxy, so it has a lot of time to actually leak. And it's very thin, which kinda has to be for a good casting, but it has its consequences, and the consequences are it's very thin, so it's gonna be very leaky. Yeah, it's gonna be stressful. I'm still thinking about it. Ideally, I know what I would like to do. Can't do it everywhere anyway. I grabbed some of that UV curing resin. I was thinking of pouring a little bit on the edges first and cure it with UV, because that thing, even if it leaks, it's gonna be, we can cure it fast, and then after it's cured, it's sealed. But I don't know, I need to think very well about it. I bought silicone sheet as well, but I don't think it's a good idea, because again, the idea is to my idea with the silicone sheet, I mean, it's a very thin, like 0.5 millimeter silicone sheet. The idea would be laser cut seals to, for instance, for the skirts, like laser cut a full seal, a rectangular seal for here, and a couple of seals for here. Here I'm gonna need to use a bunch of silicone, there's no other way, because the guys even decided to fuck us up with these beams being longer, not everything the same size. Would be much better if everything would be the same size instead of having these pockets in here. So here, I have no choice. I need to use a bunch of silicone inside of these holes, and when I put in the frames, they're gonna seal. It's gonna need to be that way. There's no other way. But yeah, it's that kind of stuff. I'm really worried about that kind of stuff. Not as much in the base, because I can just do a bunch of silicone there. I can just finger brush a bit of silicone in here and a bunch of silicone there, and then when we when we get this to the frame, it will seal. That's fine. The main problem is the other section. On the table, let me disassemble all these first. I should test with water, but with water we're gonna add moisture, then I'm gonna need to dry it. Probably I will do it. So probably I'll prepare the castings in one day, then we're gonna do the water testing, and then do the actual casting the other day, so we can empty and clean everything and let it to dry. If my oven, but yeah, I can fit this stuff in my oven. Because again, there's a lot of corners and gaps and whatsoever for the water to get in. I really, yeah. But it's probably something I also thought about that, and it's probably something that's gonna happen. I prefer to delay it one day and make sure everything goes fine. Other than casting and the next day be a pool of epoxy everywhere. It's not gonna be stream friendly, but probably gonna be safer. So yeah, decisions. I really don't want it to be leaky. So yeah, epoxy leak would be a freaking mess. And of course, even so, I'm gonna leave like the garbage plastic bag under it, so in case of. But yeah, my main concern, especially on top, so it's not even on the base. The base I'm pretty sure is going to be fine, as long as we need to silicone seal the sides of the different pieces of the frame. I actually bought a few syringes to see if I can apply a thin line with a needle, a thin line of silicone. I'm not sure if I will able to, but it doesn't hurt much to try. Fill a syringe with silicone and then just do a line. My throat is dry. Give me a second, I need to drink something. I'm back. So my big concern is, let me blow my nose as well. So my main concern is not the actual base. The base is gonna be the easiest part. Just seal the tops, seal the in-betweens, of the epoxy and the frame, sorry, and we should be good. The problem is on the top when we adjoin the iron effect. What was I saying? Okay, so attaching the y-axis to the table, or not to the table, to the base, that's going to be stressful because it has a lot of edges, and even the top of the column, yeah, that's going to be interesting to say the least as well. So yeah, but hey, we'll figure it out. No point on being stressed already. We're gonna be stressed when we get there anyway, so no point on stressing twice. That's what I usually say. Let me make sure I don't lose this. Put all these there. Going on here. But yeah, it's gonna be fun. You're gonna learn one way or another. We're gonna learn one way or another. And all the point in here is learning, so should be fine. I'm okay with learning. I'm gonna do my best not to learn the hard way, but never know. Okay, so what else do I... Okay, so I want to check one last thing before ending this. So I finished these thingies and they look kinda okay. That's the thing with working with CAD. When we get the real thing, we are used to the zooming and all that stuff, that cool stuff from CAD, and we don't realize that the parts are actually way smaller than you think they really are. Can you guys guess? take much, right? My filament is super duper wet, all full of bubbles. Well, if you paid any attention to my streams, yeah, the design, it has some flaws, to say the least. I think it's a nice machine, but you actually need to do what I'm doing, if I'm honest. CNC machined parts, ball screws, and what? And fill everything you can with epoxy. That's my input. The design could be a lot better. I mean, not the design of the machine itself. In itself, it's pretty decent for what it costs, and it's just some tweaks. Like this plate, for instance. This thing is a monstrosity. If you see where for instance, this plate is perfectly fine, except, well, one simple thing that makes this a monstrosity. I'm not even talking that the things are not symmetric or whatsoever. Not even talking about that. So why the hell did they counterboard these holes so low that now you only have between the bottom face and this face here, you'll have less than half a millimeter, less than 2 millimeters, while you only need to go down something like 4 millimeters in order to the head of the screw doesn't protrude from the top. And I'm saying 4 millimeters for an M5. These are M3s, so these even need less, like 2 millimeters is enough. So why do they go down there for the and remove all the meat in between the all the meat from the plate? That makes no sense at all. I kinda understand that, hey, okay, they don't want to use long screws. Yeah, fine, but they can use a little bigger screws and not fragilize so much the plate itself. Dumb, it's stupid, it's a monstrosity. Same on this one, same stuff. So here is one I added myself. This one I added myself. It's gonna attach the same part that these two will. Why the fuck they counterboard this thing almost until you don't have any aluminum in there, while you can use just a bigger screw and have a lot of more resistance or material in there? Nonsense. Sorry. And there are a few more stupid aberrations like that. The idea alone of the lead screws, I have nothing against lead screws, but the idea alone of the lead screws, so being 8 millimeter pitch, it's horrendous, stupid. Makes no sense. Yet they use them. Would be fine with 4 millimeters. I could go away with that. But 8 millimeters? Why? Makes no sense. Okay, I'm looking for some screws that I know I ordered. Here they are. So yeah, I like the machine. That's why I like the format of the machine. No, they are not stupid. They are dumb. And I mean, okay, it's fine if they did it the first iteration, but when they assembled it, they should have seen that. Like, I mean everyone that assembled it, right? There were beta testers and were so whatsoever. Why? If the beta testers, because they assembled it and it works, but doesn't mean they can change. And I'm not even talking about adding ball screws, or I'm talking correcting that kind of shit that makes no sense. Anyway, that's what happens when the not good. Yeah, okay. Okay, no bueno. At all. So, yeah, M3 mail. Then there are some other design options that, but yeah, some stuff is just like it doesn't add any cost, and it would improve the machine already. Then is the electronics part, but I think now with the Kraken it's a little better, even that I don't agree with the using 3D printer stepper drivers to drive NEMA 23s. That's just me. But yeah, as I was saying, I like the machine. I like the design of the machine, the looks of the machine. I would do some different stuff on it. I think it's fun, and I think it looks really cool. And for a do-it-yourself beginning machine, it's cool, but it could be way better. What's going on here? Yeah, a little stiff. So what's going on in here? Oh, it looks cool. So this is the first prototype. The very first test prints I'm making for the wake overs. Need some tweaking, of course. It's the very first prototype. So one problem with this design is I couldn't find this kind of screws with only 3mm length. So basically we need to cut about 1mm off the screws, which is a pain, especially because it takes a lot of them. I've been thinking of a solution, but in order to keep these things sizable, I actually can't find a solution for this. So other than cutting the screws, yeah, but it kind of works. This is supposed to work on the machine, on the floor of the machine. And it's not like a straight floor, it's actually the floor of my machine. I think it might work. So it's supposed to glue here the wipers. So it's gonna be, I'm gonna get two options. For one is a print in place to material and print some TPU wipers. The second option, to cut a piece of felt and glue it in here. And it should wipe going on. There we go. It should wipe the top of the thingies. Further testing is needed. I think I can make this work, especially since they will work pretty parallel. It's not like I'm doing this by hand that I can crook it and jingle it and whatsoever. So they may be a little noisy, but a little loop on the screws can help. Yeah, I think this can work. And yeah, working on a machine, it's gonna be way different because they're gonna be always need to figure out where they are. Yeah, I think this can work. Fuck. I'm planting screws. Main concern I have about this is the main concern I have about this is I couldn't figure out a way of using these 4mm screws without increasing the sizes, and I really don't want to increase the sizes. I can't increase the sizes, that's the main issue. Not that I don't want to, or now I could, maybe. Yeah, I need to think about it. Yeah, the problem is the screws protrude here a little bit and doesn't allow the thing to fully close. If I add the screws on this one will be growing a little bit as well, and that's no bueno. So yeah, the only solution is to grind down the screws, and yeah, I don't see other way, but indeed there are a bunch of them. Are like, I think it's 8 elements, so 16, 32, something like 64 screws if I remember correctly. No, the last element doesn't take, I think it's 7 elements that take the screws. So 14, 28, 56 screws. It's quite a bit to grind. No, these are I don't know the ISO on these things. So these are DIN 7984. So these are cylindrical. Let me try to show. So these are cylindrical, but not the typical socket. The head is a little wider, and it's a little shorter. Not sure if you know this type, but yeah, so they are kind of the button heads, but cylindrical. I think I can zoom in. So a typical socket head, let me grab a, so this is a normal socket head. against the other one. See the difference? So these are wider and shorter. No, I don't think I can test with buttons, but button won't do as guides. I need these to act, the heads of these screws will act as guides. So the way I designed this, let me try to disassemble this. So the way I designed this, so these heads are acting as guides inside there. And since the buttons are more round, one, it won't be as good as a guide because it will wobble more unless I make the guides actually with the shape of the button, but it will also be more likely to derail because since they are completely round, it will be easier for the rail to derail. Yep, exactly. Because the screws are when they reach to the end, it's what actually pushes or pulls the other section and all the way around. So when you have all assembled, first we'll always stretch the first one. Then when it reaches the end of the course or the travel, it will stick and pull the second one and whatsoever, and it's what pulls everything. So I need some adjustments, not much. The gaps are quite, it can't be too gappy. I need to print it slower, I think, as well. And I need to dry the filament. And actually, PLA might be a good option for printing these. Anyway, we'll check that later. Late. I'm tired. I hope you guys enjoyed it. So, looks like I fucked up somewhere. So I need to, and I'm kind of concerned that the bigger ones, we'll see. I need to print all of them. Okay, so I need to correct the Z plates. Mine is gonna stay like they are, but I need to correct them. Anyway. I need to reprint all of these. But everything is quite decent for a first prototype. Or for the first model. I think everything will fit. And yeah. So, I don't know. hopefully we're gonna start casting stuff, or at least preparing the castings on the weekend. I'm not absolutely sure, but hopefully. So today it's Wednesday. Yeah, probably. Yeah, because I really want to keep this thing going. What else? Nothing else. Thank you for watching, and let me change the camera. So, thank you for watching, and as usual, if you guys like, please like. It doesn't hurt you. If you guys want to keep watching, subscribe. Doesn't cost you anything. And if you guys have any questions, either join us on Discord, comment below. I'll try to answer everything. And yeah, so we finished all the, well, not all the machining, but almost all the machining. There's one thing I still need to machine. Probably I won't film it. Is the base plate of the Milo, because I want to add a bunch of stuff in there. Just mostly drilling and reaming and whatsoever. I'm not sure if I'm gonna film that. I haven't programmed it. Maybe I will. We'll see. And yeah, so guys, thank you for watching. Stay safe. Have a wonderful evening. Good night. And see you next time. Bye bye.